All right then, guys, I'm going to talk you through data structures. We're going to start with the really basic ones as a recap, but really important ones to know. And then we're going to, over the next few weeks, between doing this and our coursework, move up into the more complex data structures that you do need to use for your programs. And so it's important to start learning them. It would help if I spelled structures right, but hey ho. So what you need to know, there are a lot of data structures. The ones listed here are the ones that you now need to learn. So we've got arrays, which you will have had exposure to at GCSE, as with dictionaries and lists, and also tuples. But then we're also going to look, or tuples, at binary trees, graphs, linked lists, queues, circular queues, stacks, and hash tables. So there's quite a few more to learn. For each data structure, you need to know the following. So how it's structured and implemented, what the key uses are, advantages of using it, and obviously in comparison to other structures, disadvantages of using it compared to other structures, very, very common exam questions, both of those, how to program it to store data, add and remove items, and how to search it, because bearing in mind it's a group of data, so one of the primary uses of it will be searching. So key terms that you need to be really comfortable using. So ADT, which stands for abstract data type. I'll talk you through all these in a moment. Immutable, mutable, efficiency, and scalability. So first let's start with abstract data. It's a bit of a weird thing to try and comprehend this, but essentially it is a data structure that's created by a programmer. So there isn't kind of a preset library, whereas with a list in Python or arrays in most languages, or in all languages, there'll be a library which has built-in methods. So if we think about lists in Python, you have things such as index and replace and append, which allows you to add items, but what you don't know is really how that works. You don't know the background code that's all held within the library, within the module, but you just know that it works, and we don't have to do anything to make it work. We just use .append, pass the item through, and it will just be added to the list. And so using that concept, this is the idea of an abstract data type. So it does actually use existing data structures, normally arrays or lists, but it finds more complex ways of storing data. So there are agreed ways in principle to use them, and agreed ways that we would say, right, for that to be a stack, you would do it this way. But the programmer has free choice in ultimately how to actually write the code to do that. Users do not need to know how it's working, but just simply that it is. Okay. So going back to basics. Arrays are the fundamentals of most data structures. Now, some of you who only learnt Python at GCSE would have probably predominantly stuck to using lists, and they are actually different. And it's really important, if you didn't learn about arrays, that you make sure you go back and really familiarise yourself. I'm going to give you an overview now, but obviously commonly used as either 1D or 2D, so one-dimensional or two-dimensional. It's a static data structure. So what that means is once you set the size, it cannot be changed. You can add items, remove them, replace them as often as you want, but the actual size of the data structure, so 10 elements or 15 elements, is static. It cannot change. If it was changeable, such as a list, which can change in size, that would be dynamic. So another important point is that with arrays, the data stored must all be the same data type. That's as much. That's awkward. Must all be the same data type, so string, integer, float, etc. Whereas with a list, you'll remember that you can actually put any data type in at the same time. Other key points. So obviously when the array is set up, you must declare the length or the maximum items. And obviously this is where it becomes that static data structure. Doing so takes the X amount of storage places needed in memory. So if you say it's 10 items long, it will hold 10 places in memory, and they will be stored in contiguous memory. And I'm not going to tell you at this point what does contiguous memory mean, because one of your tasks will be to go and research it. And I'm sure I mentioned it in class and some people already know, but obviously in this context, what are we talking about? So the data items inside an array are elements, and array elements must all be the same data type, such as strings or integers, as we talked about. To access an element, you must reference its index position. Okay, so this is with a one-dimensional array. So, for example, imagine I have a list of 10 students allowed on a school trip and there are only 10 places. My physical list could hold anywhere from 0 to 10 students. So, either there are no students on my list or there could be anything up to 10 students at any given time. So, here I have my empty list. Here I have a number of students on there, and here I have 10 students. So, here I have 4. So just to be clear, this has 0 items, this has 4 items, and this has 10 items. And I've deliberately numbered it like this because you need to be very clear about the fact that this is different to index positions. So remember, this list here has 4 items, but hopefully if I ask you what is James's index position, you're already going to know that it isn't the number 4. So what is the index positions of Jamie? So if I look across at my list, now while this replicates a human list, which is all that arrays are built to replicate, kind of a pen and paper list, we know that though Jamie is the first person on my list, in programming terms, the array starts counting from 0. So the index position of Jamie is 0. So for James, that means that it's 3. And over here for Jacob, it means that it is 10. Okay, and then looking, can we add another item to the last list, and why? Well, no, because remember, it is static. We cannot do anything to add it. We could only replace an item that was already there, but something has to go in order to now save something else. Key points from programming. So this is how the syntax looks if you did want to use an array. So we need to do our import statement, and that allows us to access the array library. So this again is different from using a list. You then need to name the array in the same way that we would name a variable. Array and then open close brackets is a built-in method that declares the contents of an array. The I identifies the following elements or data as integers, and then of course those things in the square bracket are the data elements to be stored. And this is probably the bit we're the most familiar with because that looks very much like a list. So with 2D lists, very similar, but the way you need to think of it is more like a table. So it's made up of rows and columns, and the only difference is we don't store the headings like you would in a spreadsheet. So if I ask you to find Emily's favourite colour looking directly at this list, what would you do? Well, ideally, what you would do is first look down the row to find Emily, and then you would look across to the column to find pink. So always remember, and this is the same when we're given the index positions, that we always look down first. So then if we looked at this, if this was a physical list, again, we would look down and then we'd look across. And this is how the rules of programming work. The way that it's worked is to access an element, we come down, we state the row that we would like to access things from, and then we give the column index to say which position we'd like. So if we look here, in this question it asks, what does array 0, 1? So I'm going to come to row 0 and 1 is blue. Whereas 1, 0 is 1 and then 0. So that would be Amelia. If I wanted to return the whole list, or the whole array or row, then I would just give the index for that row and then not specify a specific column. What I cannot do is just give a column. These are separate groups of data. Each row, each record is its own piece of data that is grouped together. The columns just tell you where what is stored, what category is stored in each index. So for example here, if I printed out my array 7, it would give both Rianne and Black and not just one or the other. So syntax differs depending on the language, but the general concepts are pretty much that you can add elements, remove elements, pop elements. So what does pop mean? I'm going to get you to find that out as well, and replace elements. So tasks that I want you to do is I want you to research the advantages and disadvantages of using an array over storing elements in separate variables. Explain how arrays are different to lists, and these are used in Python, and also explain what is meant for data to be stored contiguously in memory. This is a really, really important topic. It comes up so heavily in your exams, and I really would like to stress that please take your time to research this properly and answer the questions really well and really kind of up to A-level standard, because data structures makes up around half of the marks from your exam paper, so it's quite a big part. Okay, so I'm going to post this bit onto assignments with this video, and hopefully having watched this you'll know what to do and you can go away and do your own research.